Hi everybody, how are you doing? Today we are going to discuss an issue about speed control by motors. In 19th centuries, the DC brushed motor has been popular for over decades or even centuries. The benefit of this DC motor is it's very easy to control its speed by just adjust its voltage. So for over decades or even centuries, it's been playing a major role of speed control in this field. However, the major problem with the brushed DC motor is the motor exists with two brushes, which results in the frictions and also the lower efficiency and the life concerns. So that's why people in the 20th century trying hard to find another way to replace the role of the brushed DC motor. In about the mid-20th centuries, the power electronic technology get a better progress. So people trying to apply the power electronic technology to the AC motors. Because AC motor is just using the rotational field to bring the magnet rotating. So once if you can control the frequency or the speed of the rotating magnetic field, you can bring the magnet rotating and changing speed accordingly. So that's why people are using power electronic technology to create so-called VVVF inverters, which can bring the DC power to the AC power. At the same time, they can control the voltage and speed accordingly. So applying such an output to an AC motor, you can change the AC motor speed according to the adjustment of the voltage, at the same time the frequency. And the benefit of this combination is that the AC motor, intrinsically, there's no brush. So we can gain the benefit of speed control, also avoid the disadvantage of the brushes. So this is a current popular technology used on market, which is so-called the brushless DC motor. Although it's called brushless DC motor, but actually the machinery itself is an AC framework plus the VVVF inverter used. So today we are very pleased to introduce you another alternative technology, which is so-called the true brushless DC motor. As Nan mentioned, it's actually borrowing the 19th century technology, the brushed DC motor, but take away their brushes. So this new technology, they follow the same machinery used for the brushed DC motor, but we remove the brush used. Instead, we're using the new power electronic design to take the place of the brushes. So basically, it follows the same way that the brushed DC motor is behaving. However, we don't have the issue with the two brushes. And it keeps the behavior that the plus and minus speed is exactly proportional to its voltages applied. So as you can see, if we turn on the power and we apply a voltage to it, at the lower voltage, you can see the speed is lower. And once if we increase the voltage, you can see the motor speed up. So basically the speed is just simply proportional to its voltage applied. Also, if we reduce the voltage, you can see the voltage is reduced and the speed is reduced. Not only, if we change the voltage polarity to the negative polarity, you can see the speed is being reduced and also down to the zero, and then reverse its rotational direction to inverse rotational direction. Just simply follow the way the voltage applied. So this is a very simple framework that provide a new alternative technology to use for the speed control in this field. Again, if we change the voltage back to a positive polarity, and then you can see the speed change back to the positive again. Okay, so let's reset the voltage again. And now we want to connect the two motors in the opposite way. So basically, right now they are in parallel. So here, we want to change them to the connection in a different direction. And now we apply the voltage again. You can see the two voltages are running oppositely. So once we change the voltage back to the negative polarity, and you can see the two voltage change their running direction accordingly. But the two motors are simply running in the opposite way. So this is evidence showing that it's very easy to change their running behavior just simply by change their polarity. Okay, now let's reset the voltage. Not only, let's remove the power supply. So I take away the fuse connecting between the power supply and the two motors. So now the two motors are totally unpowered. So, but the two motors are connected in an opposite way. So once if I change by running one motor, you can see another motor is running an opposite way because they are now connected at a cross direction. So they are running an opposite way. Same way, if I move this one, you can see the motor can change the behavior of another motor because now it's behaving like a generator. So the two motors are now just connected by two wires. Okay, so now we change back to parallel. So the two motors are now just connected parallelly by two wires. So now if I running a motor as a generator, you can provide the power to another one and running the same way. So likewise, if I move this one, it can also deliver the power to another. So just connected by two wires. So this is a very simple demonstration showing that the control of these two motors and also the energy transition between motors are very simple, very intuitive, and very straightforward. So this is a very good for the control system to manipulate the speed and also the running behavior of the motors. Also, it can provide as a generator to regenerate the power back to the system or to another motor. So if we connect such motors, several of such motors together, you can see it's easy to develop a new concept of the power transition system. Dynamic power transition between the two electric machineries can be easily done, straightforward, and very intuitive. So this is another benefit of this new technology. So if you are interested in this technology, please contact us at thomas64089110 @gmail.com. I'm Thomas. Thank you.